Welcome. Let's imagine that we've received the following assignment. Let's have an arbitrary Cybertruck that moves directly only forward, and our task is to find out what was its average speed. We know that it traveled the distance of 500 meters and the time we measured was 20 seconds. Since the car does not go at a constant speed and accelerates at the beginning and slows down at the end, we calculate the average speed. The formula for calculating the average speed is v from the word velocity, t from the word time, and d from the word distance. Average speed is equal to the distance traveled by the vehicle divided by time, which makes sense because speed represents how much the object has traveled in a certain time. In our case, we know that it traveled 500 meters in 20 seconds, which comes out to be 25 meters per second after dividing. Let's try to convert the units to kilometers per hour. Since we know that in 1 hour there is 3600 seconds, and in 1 kilometer there is 100 meters, on the other side of the equation their position must be changed to maintain equality. After multiplying 3600 by 25 and then dividing by 1000, we get the speed of 90 km per hour. In some versions, you can also find the letter S instead of D to prevent any confusion, because D is used for a diameter of a circle. But it makes more sense for us at the moment to use a letter derived from the word distance. Symbols used in formulas are just a convention, and in theory, we can use any letter to denote variables. Let's go back to the previous formula. This can be used to verify the result or in case we do not have a given time or distance. We can modify the formula as needed and according to what we need to find out. Let's say that we know the average speed and the time the car traveled. Let's modify the formula so that on one side there are measured values and on the other the variable that we want to find out. Time is in the denominator and operator must be changed to multiplication on the other side of the equation to maintain equality. The distance then remains alone on the right side and we get that the distance is equal to the average speed multiplied by time. Let's insert our known values into the formula and let's adjust the units so that we can work with them. We have to perform the operations with the same units, and since we have time in seconds, let's convert speed to meters per second. As the result, the distance traveled is 500 meters, which matches the previous case. Let's summarize what we've learned so far. The formula for calculating the dependence of time, distance and speed is that distance equals to speed multiplied by time. If we need to find out another variable, we can change the equation as needed, but equality has to be maintained. The operator must always be opposite if we transfer it to the opposite side of the equation. Minus changes to plus, multiplication to division, and vice versa. When calculating, we adjust all quantities to common units. Thank you for your attention, it's very much appreciated.